Good morning, everybody. I will be taking electromagnetic field tensor in a different manner as I have taken last class. It was from Griffith's textbook. So I think this is much a little more easier. You will be understanding it more clearly this class. Please listen to this class also. So we know that the electric field and magnetic field have three components each, isn't it? The components of electromagnetic field tensor is having both electric field and a magnetic field, and these two fields have three components each. And we can write this as 4x4 matrix, which is called a tensor of rank 2. Now I have already said electric field have three components and magnetic field have three components. That is space part, isn't it? So we know the equation for electric field E is equal to minus del phi minus dou A by dou T, where phi is the scalar potential and A is the vector potential. And B is del cross A, equation 2, where A is vector potential. So using these six components of electric field and magnetic field, we can develop the tensor, which is 4x4 matrix. And we can identify this tensor to be antisymmetric tensor. So for convenience, we take Ex as E1 and Ey as E2 and Ez as E3. Similarly, Bx as B1 and By as B2 and Bz as B3. So let us write first from equation 1 the value of E1, that is Ex. So it will be the x component, isn't it? So minus del phi has the x component, which is minus dou phi by dou x, which is dou x1, where x1 is x, and minus dou a1 by dou t. So ax is a1 there. So ax is a1. So it is x component, which is E1, x component of electric field, which is E1. Now we multiply this E1 with the I by C. Now when you multiply I by C on the left hand side, you have to multiply it on the right hand side also. So the equation becomes I by C E1 is equal to minus I by C dou phi by dou x1 minus I by C dou a1 by dou t. I have taken this I by C into this derivative differential. So minus dou by dou x1 of I by C phi. So I by C phi, we call it as the first component of vector A, which is here A0. So A0 is the temporal part, the time component of A. So A has the vector potential A has the space component, three space components, which is Ax, Ay and Az, and the time component we call it as A0. So A0 is phi by C. I by C I by C into phi, that is I phi by C. That is the temporal part. So we call the space part of Ax, Ay, Az as A1, A2, A3. And the time part, which is the temporal part, we call it as A0. So this one we have written minus dou by dou x1 of I by C phi, we write as minus dou by dou x1 of A0. We write it the second term, write it as second term. The first part, the second term comes first one. So dou A1 by dou of ICT. ICT is the temporal part and we call it as x0. x1, x2, x3 are x, y, z and x0 is ICT. So we have got the first equation A. Now we write, we multiply I by C to E2. So what is E2 there? E2 is dou it will be dou A2 by dou x0 minus dou A0 by dou x2. Similarly, you can find. and I by C into E3 will be dou A3 by dou X0 minus dou A0 by dou X3. The same way as we did for finding the equation A. Now we got all the three parts of electric field, E1, E2 and E3, A, B and C equation. Now let us find the three parts of B, magnetic field. Magnetic field, we know it is del cross A, that is determinant ijk dou by dou x1, dou by dou x2, dou by dou x3, a1, a2, a3. It is determinant. Expanding, we will write I into dou a3 by dou x2 minus dou a2 by dou x3. Instead of writing minus j, we write plus j and interchange the terms inside the bracket. So dou a1 by dou x3 minus dou a3 by dou x1 plus k cap into dou a2 by dou x1 minus dou a1 by dou x2. So this is del cross A. Now first take the component x component, which is b1 bx. So b1 is bx. It will be dou a3 by dou x2 minus dou a2 by dou x3, and b2 will be dou a1 by dou x3 minus dou a3 by dou x1. So we have got first equation A and equation B, and then B3 equation C. So now let us write ABC of E and B. We can from both ABC of E and B, we can write together. We can combine these three equations of electric field and magnetic field together as F mu nu. So instead of electric field and magnetic field, we are writing E or B. Instead of E or B, we are writing F mu nu. So it has two subscript there, mu and nu, in order to represent the derivative of A and A with respect to x. So A will have dou A, this will be equation which is equal to dou A nu by dou x mu. Remember, first take the second subscript, dou A nu. Dou A nu by dou x mu minus dou A mu by dou x nu. Now we can check whether this is correct. Equation 4 is correct. We can substitute now. So first let us see what is I by C into E1. I by C E1, when you take from this equation I by C E1, it is dou A1 by dou x0 minus dou A0 by dou x1. So by substituting that in the equation 4, you will get F01. So it will be F01. Now I by C into E2, what is that? When you substitute that in this equation B, you will see it is F02, and I by C E3 will be F03. Similarly, we can do it for B1, B2 and B3. So B1 will be F23. You can remember this also. First B1 means there is 2 and 3 missing, so you just write F23. B2, 3 and 1 is missing, so F31. B3, F12. So 1 and 2 are missing. So you can learn like that also. You can check it using this ABC equations. So F mu nu, instead of writing electric field or magnetic field, you are replacing electric field and magnetic field with the F mu nu. So that is why we call this F mu nu as electromagnetic field tensor. So electric field is also there, magnetic field is also there. So F mu nu is electromagnetic field tensor. Now let us just interchange the subscript there. F mu nu, we just take minus out and take it will be minus of dou A mu by dou x nu minus dou A nu by dou x mu. That means minus of F nu mu. So this tensor is antisymmetric. You can prove like that. So F mu nu, when mu and nu are equal, it will be F mu mu. F mu mu will be 0. So when this tensor is considered, this tensor which has diagonal element will be 0. F mu mu will be 0. That means F00 is 0, F11 is 0, F22 is 0, F33 is 0. Now let us substitute the whole values in this matrix. You will get equation 5. So this is electromagnetic field tensor of rank 2. Equation 5. I hope you understood. This is what we have learned in last class from the Griffith chapter also. So you can write, instead of writing that, if you don't understand, this is more clear and you can write this in your essay. This can be asked as an essay, electromagnetic field tensor. Now next essay is Maxwell's field equation in covariant 4 tensor form. This also can be asked as an essay. This is also more simpler than which we can see in Griffith. So you just need to learn this. So let us write all the field equation, all the Maxwell's field equation in a tensor form. That is what it is asked. So first write Maxwell's equation. Del dot E is equal to rho by epsilon 0. Del dot B is equal to 0. Del cross B is equal to mu 0 into J plus epsilon 0 dou E by dou T. And del cross E is minus dou B by dou T. As equation number 1, 2 and 3. Fourth equation I write like this. Del cross B minus mu 0 epsilon 0 dou E by dou T is equal to mu 0 J. In that form I write. So I take this fourth equation and substitute for mu 0 epsilon 0 as 1 by c square, and it will be del cross B minus 1 by c square into dou E by dou T, which is equal to mu 0 J. Now we take x0, x1, x2 and x3. We know that x0 is ICT, x1 is x, x2 is y, x3 is z. So now let us take that and take equation 4. Del cross B, now we multiply. So instead of mu 0 1 by c square, we write I by c. I we have introduced in numerator and denominator, and then c we have splitted. So minus I by c into dou E by dou of ICT. So ICT is x0, we can substitute that. So del cross B minus I by c dou E by dou x0, we can write like that, which is mu 0 J. Similarly, we take this other equation of 3. Del cross E plus IC we have introduced there under numerator, and denominator also we have introduced IC. So it will be dou B by dou of ICT. ICT is x0. So del cross C plus IC dou B by dou x0, which is equal to 0. So equation 5 and 6 we got. Now del cross B we expand and take the components x, y and z components. So we have written that, and del dot D also we have written in terms of its components. Equation 7. Writing x component of equation 5. So first del cross B equation 5. Its x component, what is its x component? X component will be del cross B's x component is dou B3 by dou x2 minus dou B2 by dou x3. Now minus I by c dou E by dou x0's x component is, it is minus I by c dou E1. E1 is Ex. Dou E1 by dou x0 is equal to mu 0 Jx. Jx has component J1. We write Jx as J1. So equation 8 we will get from equation 5 by taking only the x component. I hope you understood. Now writing the y component, it will be, we take the y component which is minus of dou B3 by dou x1 plus dou B1 by dou x3 minus I by c dou E2 by dou x0 is equal to mu 0 J2. Also writing the two components, that means the third z component, z component, z component dou B2 by dou x1 minus dou B1 by dou x2, which is the k cap into that term, dou B2 by dou x1 minus dou B1 by dou x2 minus I by c dou E3 by dou x0 is mu 0 J3. So equation 8, 9 and 10 we got x, y and z component of equation 5. Similarly, we take equation 6. Equation 6 x component, and equation 6 we just equation we are taking equation 7 instead of equation 6. We are taking equation 7 first. Equation 7 is I by c dou e1 by dou x1. We multiply with the I by c there. So I by c dou e1 by dou x1 plus I by c dou e2 by dou x2 plus I by c dou e3 by dou x3 is I by c rho by epsilon 0. So we have multiplied left hand side and right hand side with the I by c. So now we have we know c square is 1 by mu 0 epsilon 0. So epsilon 0 c is equal to 1 by mu 0 c, isn't it? So we write now I by c dou e1 by dou x1 plus I by c dou e2 by dou x2 plus I by c dou e3 by dou x3 as epsilon 0 c is 1 by mu 0 c. So we will get I into mu 0 c rho. We know that IC rho is J0. ICT is X0. So IC rho will be J0. So J0 we have substituted there. So that means equation 11 we got right hand side as mu 0 J0. We know from previous section all the components of the field tensor. I have written that. Now we can write from 11 and 8, 9, 10. So we got the right hand side as mu 0 J0, mu 0 J1, mu 0 J2, mu 0 J3. 8, 9, 10 and 11. We combine it to make it into a field tensor form. So we can, left hand side you can see this electric field and magnetic field. Right hand side is mu 0 J, all the components of mu 0 J. So it will be mu 0 J mu right hand side, and left hand side will be dou F mu nu by dou X nu. Dou F mu nu by dou X nu. It will be by taking the component here I by C E1, I by C E2, I by C E3 and also B1, B2, B3, B minus B1, minus B2, minus B3 are all the components of F mu nu. You can see from the field tensor there. So we can write directly that field tensor there, and the summation over nu there. So sigma F nu 0 to 3 dou F mu nu by dou X nu will be mu 0 J mu. The variable there is nu. Mu is also variable, but we are taking the summation variable which is our nu. So this is very important equation, and this is the combined equation of all the Maxwell's equation. All the 4 Maxwell's equation we have combined it into one equation, which is equation 12 there. So this equation 12 represents the field tensor equation in relativistic dynamics. All the Maxwell's equations are combined there. So we can verify whether 12 is correct. If 12 is correct, we can verify it by putting values mu is equal to 1 and mu is equal to 2. All the values you can check. Just we have done only one here. Mu is equal to 1 we put, and then sigma nu 0 to 3 dou F1 nu by dou X nu will be mu 0 J1. So substituting all the values of 0 to 3 for nu, F1 1 by dou X1, dou F1 2 by dou X2, dou F1 3 by dou X3 plus dou F1 0 by dou X0, which is mu 0 J1. We can see that F11 is 0. So first term goes to 0, and the second term dou B3 by dou X2 minus dou B2 by dou X3 plus dou by dou X0 minus I by C E1, which is mu 0 J1. This is exactly equation 8. So we got 8th equation. So this is correct. So equation 12 is correct there. So finally we found all the 4 Maxwell's equation in field tensor or relativistic in all the 4 Maxwell's equation in relativistic electrodynamics becomes one equation which is in the form of field tensor in terms of field tensor, which is, remember this equation 12 very well, which is a sigma nu 0 to 3 dou f mu nu by dou x nu is mu 0 j mu. I hope you understood. This is much easier than the other I think other Griffith's explanation. Griffith's explanation itself is written there, but in a little bit easier way, so you will understand it more clearly. And I will teach you one more thing. Finally, this is going to finish now. We have last part, which is I think the Minkowski force there. The Minkowski force, we know K mu, we can write QVB. Instead of B, we are writing the field tensor there, and instead of V, we are writing the 4 vector velocity. So Q proper velocity F into F mu nu, which is field tensor. We can substitute that to find K0, K1 and K2 there, K2 and K3 there. All the values is written there. You can understand it from here, from the note itself. So it is actually the Lorentz force law in relativistic notation. So it is Q by root of 1 minus U square by C square into E plus U cross B. This you will understand. All the other things I have already taught you. Dou f mu nu by dou x nu is mu 0 j mu. I have taught you that is better. And we can write here one more thing, the last thing. Dou by dou x mu of dou a nu by dou nu, dou by dou x nu of dou a mu by dou x nu is mu 0 j mu. This is also correct, equation 3. And the relativistic Lorentz gauge condition is dou a mu by dou x nu, which is equal to 0. Normal Lorentz gauge condition was del dot A is equal to minus 1 by C square dou V by dou T. In relativistic Lorentz gauge condition, it is dou a mu by dou x nu is equal to 0. And equation 3 then reduces to del square a nu is equal to minus mu 0 j mu. It is not minus mu 0 j nu, it is plus mu 0 j nu. You just check in your Griffith text, but I don't have it with me, just check it. So we have finished our topic of relativistic electrodynamics. Now one more topic remains. It is the cylindrical cylindrical guide, which is electromagnetic wave guide. In that form, cylindrical guide was given as a seminar, but I was told that it is very lengthy, so I will take it, but I don't have the textbook. I will take it and I will send you. And the remaining people who has to, I think nobody has taken seminar of my part, my subject. So I wish all of you take the seminar, whatever portion you like. Whatever I taught you in relativistic electrodynamics or any part in electrodynamics, you can take whatever you like and just take the seminar for 10 minutes. And the one which I have given already, rectangular waveguide, they can take that itself. I will not take that portion. You have to learn it by yourself. You have to take the seminar also. 2 persons are given already the seminar, rectangular waveguide. Cylindrical waveguide I will take. I was told that it's very lengthy, so that's why I will take it. Okay. All the other 4 students, they can choose their topic of their own, or any topic from my portion for 10 minutes. They can take for 10 minutes. Okay.